Okay, so for quarter 2 for your quarter assessment, make sure to review your formula sheet so that you're aware of what's given to you and you're familiar with it for your test. So day 1, we start with limits. These graphs are given to you. On the test, some graphs might be given, some graphs you'll have to put in your calculator, so make sure you're aware of how to graph these in your calculator if necessary. For number 1, we want the limit as we approach 4, and this little plus sign means from the right. So as we approach 4 from the right, this y value is 1. For B, that little negative means as you approach 4 from the left. So as I approach 4 from the left, this y value here is 13. Since these limits are not the same, for the answer for C does not exist. The limit 4 from both sides, they're not the same, does not exist. And now for D, the actual y value at 4 is your closed point, and that is 1. For number 2, as we approach 4 from the right, that's a y value 2. As we approach 4 from the left, it's a y value of negative 2. Those values are not the same. And we don't have an actual value at 4. It would make that denominator 0. So D does not exist. For 3, for this 4 from the right, there's no graph to the right of 4 to approach from. So this value does not exist. But as we approach 4 from the left, for B, we're approaching 0. Those values are not the same. And the y value at 4 is 0. Okay, so for number 4, we want to find, this is the first derivative and the second derivative. A is pretty straightforward as a polynomial. We're going to use our power rule. The exponent comes down and multiplies by the coefficient. Reduce your exponent by 1. We'll do the same thing for the second derivative. Now, B is a product rule. You have a function times a function. So the way I like to set up my product rule is separating the two pieces of the product. Individually take the derivative of each. And then the product rule says we want f times g prime. So that's going to be 6e to the x plus g times f prime, this way. And actually, to make our second derivative easier, I should not have multiplied the 2 and the 3. Instead, I'm going to make this 3 times 2e to the x, because we can factor out this 2e to the x. And we're left with 3 plus 3x plus 4. So then simplifying that, we get 2e to the x, and we can add that 3 and 4, so we get 3x plus 7. And guess what? We have to do it all over again for the second derivative. So for the second derivative, I'm going to split up our product rule. Individually take the derivative of each. This way and this way. So the second derivative is 3 times 2e to the x plus 2e to the x times 3x plus 7. And again, we can factor out this 2e to the x that they share. And that leaves us with 3 plus 3x plus 7. So as a final answer, that's 3x plus 10 inside that parentheses. So here's your final first derivative, and here is your final second derivative. Okay, so now for C, we've got ln of x. And if you look at your formula sheet, the first derivative is 1 over x. But to take the second derivative, we have to change that so it's the variable's not in the denominator. So I'm going to make it x to the negative 1. So our second derivative is negative 1 x to the negative 2. We don't like to leave a negative exponent, so just this term moves back to the denominator and the exponent becomes positive. For D, we have a chain rule because this is sine of another function. So this is 5x squared would be our u. So our first derivative is sine, the derivative of sine is cosine, so cosine of u times u prime, which is 10x. So to make that look nicer, we just put the 10x as a coefficient. So we get 10x cosine of 5x squared. Now the second derivative gets a little trickier because we have a product. We have the function 10x times the function cosine of 5x squared. So for my product rule, I'm going to individually take the derivative of each part. So this is negative 10x sine of 5x squared. And we're going to multiply this way. So the second derivative is 10x cosine of 5x squared. And then we're going to do plus, but we're going to get a negative. So I'm just going to do minus 10x times 10x is 100x squared sine of 5x squared. And lastly, for E, it's a quotient. We need the quotient rule. We've got x plus 3 is our numerator, and x minus 4 is the denominator. This one's on the top, it's high. This one's on the bottom, it's low. So we're going to individually take the derivative of each. And the first derivative says low d high minus high d low all over low, low, which means the denominator squared. We have to distribute this negative. And then in the numerator, we can combine like terms. So we get our first derivative is negative 7 divided by x minus 4 squared. We're going to do that all again for the second derivative. Got high and low. Individually take the derivative of each. Now this is a chain rule for the denominator. What's the derivative of x minus 4? It's just times 1. So thankfully, if you forgot it was the chain rule, it wouldn't change your answer. So we get the second derivative is low d high minus high d low all over low squared. So because it was squared, squaring it again is to the 4th. Now simplifying, we get 14 times x minus 4 over x minus 4 to the 4th. Because this is x minus 4 to the 1st in the numerator, this whole factor can cancel with one of those factors. And our final answer is 14 divided by x minus 4 to the 3rd. Okay, so for A, if I write out our statement here with the actual functions, when you're evaluating a limit, if you can take this number and plug it in without making the denominator 0, you get your answer. So 2 plus 1 is not going to be 0, and 2 squared gives us 4, so the answer is 4/3. Now, if the denominator was 0, you would have to evaluate the limit graphically. You could make a table of values and approach that value from the left and the right. So now the same thing for b. If we plug in 2, we get 3/4. For c, since x is going to infinity, we're going to go back to our rules where we looked at the difference in the exponents. So when the degree of the numerator is smaller than the degree of the denominator, our limit as x goes to infinity is 0. If we have it the other way, where the degree of the numerator is larger than the degree of the denominator, that limit does not exist. So now for e, because h of x is a product of these functions, but everything's in terms of x, I can simplify that by distributing, and then it makes it pretty straightforward to find the first derivative and the second derivative. Now for f with the quotient, we're going to have to do a little bit more work. So if we write our function, so doing the quotient rule, we've got high and low, d high and d low. So the derivative is low d high minus high d low all over denominator squared. I'm going to distribute this 2x, because then we can simplify our numerator. And we are going to get x squared plus 2x over x plus 1 squared as our first derivative. So now to get the second derivative, we have to do that all over again. I need to get myself some space. So for the second derivative, we have high and low, and derivative of each. So then the second derivative is low d high minus high d low all over low squared. So since it was already squared, I'm going to square it again. And then the numerator and the denominator, they all have an x plus 1 term. So what I notice is this has just 1, and this has 2. So I'll reduce that to 1 and this to 3. Now the reason you can do that is because we could technically factor out an x plus 1, an x plus 1. And it would look like this. So now that that x plus 1 was factored out, this whole term can reduce the denominator to 3. So our final answer is 2x plus 2 times x plus 1 minus 2 times x squared plus 2x all over x plus 1 to the third. Now you could multiply your numerators together, but you don't have to. Another way, you'll notice the answer on end line is slightly different than this answer. Man, this problem could be written so many different ways. This 2x plus 2, I could factor out a 2 from. And then, since these terms are the same, the way I wrote my answer on end line is I had x plus 1 squared and that's the final answer on end line. Both are right. You could stop here. You could go to here. That's just a really long second derivative. Okay, now I'm set up for number 2. We have to use the definition of the derivative to find the derivative. I'm specifically telling you, you must use this limit definition. You know what the answer should be. We know that we're going to eventually want to get to 4x minus 1. But your algebra work has to match that. So we're going to start by finding f of x plus h. So that means I'm going to plug in x plus h to every x and simplify. This negative gets distributed. X plus h squared means times itself. And then I'm going to distribute the 2. So using the limit, we've got the limit as h goes to 0. And we have our f of x plus h, which we just figured out, minus f of x, which is the original function, all over h. It's important that you put those parentheses around the original because this negative gets distributed. Notice you have to write the limit as h approaches 0 every step until you plug in that 0. And we can't plug in 0 yet because the denominator is h. So simplifying, 2x squared minus 2x squared is 0. Then we have 4xh plus 2h squared. And we have negative x minus negative x is also 0. So we're left with just that h. So now we can factor out an h in our numerator. And simplify. So as a final step, what we have here, now we have no more denominator, so we can plug 0 in, and we have 4x minus 1, which is exactly what we wanted as our first derivative. Okay, we're going to do it all over again for b. We know we want our answer to be 6x plus 2. So first we need f of x plus h. And I wrote out the x plus h squared so that now I can just multiply it. Distribute the 2. And lastly, we'll distribute the 3. So now we have the limit as h approaches 0 of, here's our f of x plus h, minus the original function, This negative gets distributed. Oops, I forgot all over h. So when you simplify your numerator, you should be left with 6x plus h plus 3h squared plus 2h. Now we can factor out an h from the numerator. Those simplify, and we're at a spot now where we can plug 0 in, and we get our derivative of 6x plus 2. Okay, and for number 3, find the equation of the tangent line. So to find the equation of the tangent line, I like to use point slope form if it doesn't tell me what I have to use. So we are given a function and we're given the x value. So the first thing we need is the y value. So using the original, we get 7 as our y value. Then for our slope, we need our first derivative. So f prime of 5, well, still 2. So our equation is y minus 7 equals 2 times x minus 5. For b, I'll just do that one down here. First, we need our y value. It's 4. Then we need our derivative at the point. Well, it's also going to be 4. So our function is y minus 4 equals 4 times x minus 2. And for c, we need our y value, negative 6. We need our derivative. So we get y minus negative 6 equals m, x minus 0. You could leave it like that. This one will be nicer to simplify. That's x minus 6. Okay, for day 3, average rate of change just means the slope from negative 2 to 1. So for A, we're going to do the y value at 1 minus the y value at negative 2 divided by 1 minus negative 2. I recommend using your calculator to get those y values. You can put the function in y1 and look at a table. You can plug them in on the main calculate screen, do 1 squared plus 2 times 1 plus 3. So in your numerator, you should get 6 minus 3. The denominator simplifies to 3. Well, 6 minus 3 is 3. So 3 divided by 3 gets us an answer of 1. Instantaneous rate of change is the slope at a point, which is the derivative. So first we have to find f prime of x. And then we would plug in 3. We get 8. Derivative just means slope. So when I go to answer number 2, if I look at the slope at A, that's negative. B is at a sharp point. That's an undefined derivative. C and D are positive slopes. E is at a maximum, so that's 0 slope. And then F and G are both negative slopes. So to determine a value that makes this piecewise function continuous, we're going to set our pieces equal. But we want them continuous at the break here, which is 1. So we're going to plug 1 in for x and solve. So A is 2. Now for 4, we have 2 pieces. So we're going to set these first 2 pieces equal at 2. So I'm going to plug 2 in for the x. And we're going to take our bottom pieces and set them equal at -4. And now we have two equations with two variables. So I like to write them lined up, because my preference for a method of solving is the elimination method. You could do substitution. So the elimination method, it works by, I want to add or subtract these equations together to eliminate a variable. So I notice that the b's have the same coefficient. So if I subtract these equations, we get 6a equals 6, so a is 1. Those b's eliminated, they cancel each other out. Now that we have a is 1, we have to plug it back into either equation to get b. So I'll choose this one. So b is also 1. And now lastly, for 5 and 6, when you have a table of values and no function, average velocity is the same. We're going to find the slope between 10 and 25. So the y value at 25 is 260. The y value at 10 is 55. And when you simplify that, you get 13.6 repeating. Don't forget your units. It's feet per second. Now for 6, to estimate the instantaneous velocity, when I don't have a function, we're going to calculate multiple slopes. We're going to do the slope to the left of 20. We're going to do the slope to the right of 20. And then we're going to average them for the instantaneous velocity. So 15 plus 16 divided by 2 is 15.5 feet per second. All right, for the last day, differentiate means find the derivative, and thankfully it's only first derivative. It's not the work of also finding the second. So for number 1, we've got 2x. Now the derivative of cosine is negative sine. So negative of -2 is going to change that positive. For number 2, we have a chain rule because we have these u functions in here. So we're going to start we've got the coefficient carries down. The derivative of sine is cosine times the derivative of that inside 2x, which is 2, plus the 3 carries down. Oh, the derivative of cosine is negative sine, so we'll do negative sine times the derivative of 4x. So simplifying that, we get 12 cosine 2x minus 12 sine 4x. You can multiply the 6 and the 2 and the negative 3 and the 4. For 3, this is an ln of u. And if you look at your formula sheet, the derivative is u prime over u. So the derivative of x squared plus 1 is 2x, and the derivative, and then the u, which is just the x squared plus 1. We're going to do the same thing for 4. So u prime, the derivative of e to the x plus 1 is e to the x over that argument of e to the x plus 1. Okay, for 5, The derivative of sine is cosine times the derivative of that 3x, which is 3. So we can write that as 3 cosine 3x. Same thing for 6. Derivative of e to the x is e to the x. Now 7 is a chain rule because we have this function inside that function. So the derivative is the normal power rule. The 2 comes down, but then we have to multiply by the derivative of the inside, which is just e to the x. So simplifying that, we get 2e to the x times 5 plus e to the x. Now 8 and 9, they're like a matching kind of problem. For 8a, if I write out the product rule at 4, what that's saying is f prime of 4 times g of 4 plus f of 4 g prime of 4. Well, if you look at what we were given, f prime of 4 is 7, g of 4 is 2, f of 4 is 3, and g prime of 4 is 6. So we get 14 plus 18 for an answer of 32. We're going to do the same thing for b. Since this is f over g, so we get low d high minus high d low all over low squared. Now I just need those values. So let's see, g of 4 is 2, f prime of 4 is 7, minus so let's see, 14 minus 18 gives us a numerator of negative 4, denominator of 4. Oh, so the final answer is negative 1. Squeeze that in on the side over there. And now we'll do the same thing for 9. So g prime of 3 is f of 3, h prime of 3 plus f prime of 3, h of 3. So matching up those values, we get 15 plus 4, which is 19. And then lastly, for the quotient, we've got low d high minus high d low all over low squared. So let's see, h of 3, prime of 3, so we get 4 minus 15 for an answer of negative 11.